And let's get started with question number 1, where it's asked us to simplify 6 over negative 3 plus 2i. Now the instructions, I wrote the instructions simplify. Sometimes the instructions would say divide. Sometimes the instructions would say rationalize the denominator. All of them mean the same thing. Whenever you're given a fraction, you look at the bottom, the denominator. If there's a square root in it, or if there's a an I in it, you've got to rationalize it. Good morning, Messiah. How are you today? So if we're doing this problem, what we're going to want to do is multiply by what we call the conjugate of the denominator, which means that we're going to multiply by the exact same thing that we see here, except the sign between the two terms is going to be the opposite of what it is right now. So I'm going to be multiplying this by negative 3 minus 2i. That's the conjugate of that binomial. But whatever I do to the denominator, I have to do the exact same thing to the numerator. So in the numerator, I'm also going to be multiplying by negative 3 minus 2i. Again, since this was plus, this has to be minus, and these two have to be identical. Now, if we're multiplying, I like, as I said, if you see me do this, I always like to do the bottoms first, because when you're multiplying conjugates, it's quick. You only have to do first and last. You don't have to do the whole FOIL, because the outer and the inner always cancel out when you have conjugates. So first, negative 3 times negative 3 becomes positive 9. And positive 2i times negative 2i becomes negative 4i squared. And remember, wherever we see an I squared, as soon as I see it, I replace it by a negative 1. So this becomes, let me just, on the bottom, 9, well, negative 4 times negative 1 is plus 4. No i's anymore, but that's what we're trying to get. And 9 plus 14 are now just two regular numbers. That gives me 13. What about the numerator? The numerator, I'm going to use the distributive property. I'm going to multiply the negative 3 minus 2i by the 6. So 6 times negative 3 is negative 18. And 6 times negative 2i is negative 12i. So my answer, let me just go over here and put the answer over here. The answer can be written in two ways. Negative 18 minus 12i all over 13. Or if you're told to give it in what's called a plus bi form, then that means what they want you to do is to separate it and put each number from the numerator over the denominator 13. So then that would be negative 18 over 13 minus 12i over 13. Both of these answers are correct answers. It's just if they say a plus bi form or format, then they want this answer. Any questions about these? Okay, so then let's look. And I did see somebody did on the chat, I think, was it you, Devana? Um, Devana sent us the right answer, negative 18 over 13 minus 12 over 13i. That is the correct answer. So again, you multiply by the conjugate of the denominator to get rid of the I in the denominator. Whatever you multiply in the denominator, you multiply in the numerator as well. Okay, so now let's look at this problem. This is, we're asked to solve this quadratic equation. We know it's a quadratic equation because it has an x squared in it. And the first step in solving a quadratic equation is to get everything on one side equaling 0. And I usually like to bring everything to the side where the x squared is, because I want to start out with a positive x squared. So I'm going to add 4x to both sides and minus 3 from both sides in order to get the quadratic equation 2x squared plus 4x minus 3 equaling 0. Now, my first step is always, this is my first step, is when I look at a quadratic equation, I see, is it going to be easy for me to factor? So if I were doing factoring, I would have to use the AC method, where I would have to multiply the 2 times negative 3. That would give me negative 6. And I'd have to find two numbers that multiply to 6 but subtract to 4. And there are no such numbers. I don't know any numbers that when you multiply them, whole numbers, when you multiply them together, they're going to give you 6, because it could always be 6 and 1 or 3 and 2. When you subtract them, you're not getting 4. You're getting either 1 or you're getting 5. So this is a case where it's not factorable, so we're going to use our quadratic formula. Now remember what our quadratic formula is. I'm just going to put a line over here so I have room. Here's my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. And this formula is probably the most important formula that you will learn this term. It's the key to being able to completely solve a quadratic equation. A little bit later today in the class, I'm going to show you alternate methods of solving quadratic equations that can't be factored, because that's the only way we've known until now. But ultimately, if you really need a backup to solve the quadratic equation, to solve an equation that has an x squared in it, you can always use this formula. So the first thing I'm going to do is I'm going to write down what my A, my B, and my C is, and then I'm going to substitute it into the formula to get the answer. So the A is the number that's in front of the x squared, so in this case it's 2. The B is the number that's in front of the x, and it's 4. Remember, you included in the number is its sign. And the C is the standalone number that's not attached to any x. If this would have been, let's say, 2x squared minus 3, and there was no x term, then your B would have been 0. In other words, it's top. Your A is never going to be 0, because if your A is 0, you don't have a quadratic equation. But your B could be equal to 0, and your C could be equal to 0 if one of those terms is missing. In this case, they're all there. Okay, so here we go, negative b. So it's going to be negative.
Professor, Leila is trying to get in.
What? Who is?
Leila.
I don't see that. Let me. Oh, okay. I don't know why I didn't see it. Okay, I admitted her. Thank you. Okay, so here we have negative b. So did you get in? Layla, did you get in? Yeah, I see she's in. Okay. So going back to this, so we're doing negative b, so that's negative the 4. What I'm doing is wherever I see a letter, I'm putting a parentheses and filling it in with the proper number. Then we have this plus minus. Remember what that means. It means that there are two answers that we can get. One when we do plus and one when we do minus. And here's my square root. It's b squared, so it's 4 squared minus 4. Now my a is 2 and my c is negative 3. And that's all over 2 times a, which is 2 times 2. So step 1, figure out what your a, b, and c is, and then stick the numbers into the formula. And now it's just a matter of simplifying. I know I'm saying just. It might be involve quite a bit of work, but that's basically using the formula means you're simplifying. Okay, so here we go. Negative in front of a parenthesis of a 4 is negative 4. Okay, here's the biggie. What's inside the radical? So first it's 4 squared, which we know is 16. And then we do negative 4 times 2 is negative 8. And negative 8 plus 3 times negative, and negative 8 times negative 3 is positive 24. And 16 plus 24 is 40. If you do the quadratic formula and you see that the number inside the radical is not a perfect square, which 40 isn't, then you know that you could never have done this by factoring. So my answer comes out to be negative 4 plus or minus radical 40 over 4. If you're told leave your answer in radical form, this is an answer in radical form. If you're told to leave your answer in simplest radical form, then you have to see if you could simplify. And if you look at this, the square root of 40 could be broken up into the square root of 4 and the square root of 10. And the square root of 4 is 2. So this becomes negative 4 plus or minus 2 radical 10 all over 4. Now I'm going to write it up here because it's getting a little bit messy. I'm erasing this and I'm writing it. So we have this answer, negative 4 plus or minus 2 radical 10 over 4. And we want to know, could we possibly reduce this. And you can reduce an expression like this, where it's a binomial on top and one term on the bottom. If you can find any single number that goes into every single one of those three terms. So this is a 4. Remember, I have to only look at the numbers outside the radical, because I can't divide a number outside a radical by a number inside a radical. So I can only look at the numbers. So this is a 4, a 2, and a 4. Obviously, all those can be divided by 2. So this will give me -2. This will give me 1, and this will give me 2. I have to be able, I can't just divide 2 of them. I have to be able to divide all 3 of them before I can reduce it. So that in simplest radical form, my answer becomes -2 plus or minus radical 10 all over 2. This is what's called simplest radical form. Remember, this symbol plus minus, a plus over minus, is just a shortened way of saying there are 2 answers. One answer being -2 plus radical 10 over 2, and the other answer being -2 minus radical 10 over 2. So
Professor, I got those same answers, but I was trying to send it in, but it wasn't working out.
you mean when you were doing it on a,
No, I got the answer, got the -2 radical 10, but I couldn't like put in the radical.
in
I
the
just,
chat?
yeah.
I'm trying to think of how you can put in this symbol. What I did is I wrote plus, I tried to send somebody an email with it. Just write plus over minus.
Okay.
You could do it that way, or you could write it as 2 separate answers. Though, of course, this takes twice the amount of time because these are quite complex to, our chat is not
Yeah, we don't have that in the chat.
to the algebraic terms.
Yeah.
You know, if you look at, let's say if you want to do something on Blackboard and you look at it, they have a function that allows you to do all these things, but the chat doesn't. I agree. It is a limitation here. Okay, are we okay with these examples now? All right, so does anybody have a question before I go on further? I want to continue talking about quadratic equations and talk a little bit about an alternate way. Again, this is like sort of an enhancement. It's an additional method. You don't necessarily have to know this method. Good morning, Melissa.
Good morning.
I'm going to make you the host, okay?
Okay.
Find you. There is something called the completing the square method that is an alternate method to finding the solution to a quadratic equation. And that's something that I'd like to talk about today. And I have to go back a couple of steps in order to do that. Number one, let's go back to our original, very simple quadratic equation. The simplest type of quadratic equation that we could have is something like x squared equaling a number. Now, I told you if you want to solve a quadratic equation, which you know would be a quadratic equation because it has a square in it, you have to get it equal to 0. And then you get x squared equals, x squared minus 16 equals 0. And of course, then the next step would either be to use the formula or to factor. This happens to be really easy to factor. This can factor to x plus 4 and x minus 4. And then you set each of them separately equal to 0, x plus 4 equal to 0, and x minus 4 equaling to 0. And when you bring the 4 over here, you get one answer is x equals negative 4. And here, if you add 4 to both sides, you get x equal to positive 4. You get two answers, which we can write either as negative 4 and 4. You don't have to put it in that bracket. Or we could have written it plus or minus 4, because this is just a symbol that tells us that it stands for two things. Either one, the 4 with a positive sign, we're playing 4, and 4 with a negative sign, the negative 4. We sometimes opt for this if you have the ability to put this symbol in because it's just quick. It's a shorthand way of writing. Instead of having to write the 4 twice, you just write it once and you put that plus minus. It means one answer is positive 4 and one answer is negative 4. Now, let's go back to this. I want you to think about it. I gave you x squared equals 16. How many people would have said, without all this long, extended amount of work, if I see x squared equals 16, to me it right away sounds like x has to be equal to 4. Because all I'm doing
The square root of 4 is 16.
Right. Except I wouldn't be completely correct. Because not only does 4 work, negative 4 could also work. Because negative 4 times negative 4 is also positive 16. So if I know x squared equals 16, I could just do x is the positive or negative square root of 16, which means that x is either positive 4 or negative 4. Without doing all of this work, by just thinking, hey, x squared equals 16, that means x has to be the square root of 16, but it could be either the positive 1 or the negative. And since the square root of 16 is 4, my answer could be either plus or minus 4 written this way, or negative 4 and 4. So just using my brain without going through all these motions, it would be much quicker. This is actually called the square root method of solving a quadratic equation. When can you use this method? When you just have an x squared. Notice it wasn't a trinomial when we got it equal to 0. It was only a binomial. There was no x term. It was just an x squared and a number. Anytime you have that situation, you could solve your equation like this. Let's try another one. suppose I gave you 2x squared plus 50 equals 0. Okay, a little bit more complicated, but a similar idea. It's what we call an incomplete quadratic. It does not have the x term. It just has an x squared and a number. Instead of trying to factor it, I'm going to do what I did before. I'm going to bring the 50 to the other side. Which will give me 2x squared equals negative 50. I want to get the x squared by itself, so I'll divide by 2. In other words, I'm going to solve this equation for the x squared. Get the x squared alone. I get x squared equals negative 25. And then what I do is I take the square root of both sides. On this side, I get x, and on this side, I get plus or minus, because whenever I'm having x squared, I have to get 2 answers. The square root of this number. And actually, this number is not, I could not have solved this by factoring, because this is not a real number. The square root of negative 25, though, we know what it is. It's the square root of 25 times the square root of negative 1, which is 5i. The square root of negative 1 is I. So my answer comes out to be plus or minus 5i. My 2 answers, again, I could write it this way, or I could write it as 5i and negative 5i. These are my 2 answers. And I did it using the square root method. I can use the square root method when I only have an x squared term and no x term. Let me give you one to try while I take attendance.
Professor, let me write that off. Please give me 1 minute.
I'm gonna write the question over here and
Okay.
leave it on, okay? Let's say I gave you x squared equals 12. See if you can solve that and get your answer in simplest radical form. I'm going to take attendance while you're doing that. Azia, I know you're here. Nashia,
Yes.
Here.
good. Do you need anything reset for you to get your up to date on your?
Yes, please. I was going to email you after class.
Okay, please email me because I know what's going to be. As soon as class is over, I'm going to forget.
Okay, I'll email you now then.
And I'll, whatever you want me to do, I will reset for you.
Thank you so much.
Okay, I just want to see you doing the work. Annabelkis, Emma, I know you're here. Messiah, I know you're here. How are you doing, Messiah? Messiah?
I'm good. Thanks for asking.
Yeah. Anytime you need anything reset or anything, just let me know.
Okay, thank you. I will get to your math work today.
Okay, I know you probably have other things that are taking priority, but just keep in mind, we only have 4 weeks of class. So I don't care when you get things done, and this goes to everybody and not just to Messiah. By the end of the term, you want to have everything complete. I will give a certain amount of leeway. And when I see toward 2 weeks before the end of the term, I'll tell you how many homeworks you have to complete to get the full 10 points, how many quizzes if you've taken all the tests and quizzes, I usually drop one of them. So, but I'll let you know exactly as we get closer to the end. But try, if you see you're behind on material and you need things reset, just email me. I'll gladly do it for you. Corey, I know you're here. April, I know you're here. Khadija, Khadija Katoy, Umar. Umar here. Yakima, I know you're here. Cheryl, I know you're here. Stacy, I know you're here. Denisha here. Devon, I know you're here. Natalie, I know you're here. Erica, I know you're here. Jonathan, I know you're here. Somebody say something? Okay. Jonathan, I know you're here. Luke, I saw you come on. Layla, I know you're here. Ashley, Ashley Ortiz. Katura,
Yeah.
hi, good morning.
Good morning.
Um, Jennifer,
She said she's coming. 'Cause she
okay,
has some trouble with her son. She said she,
okay, I'll mark her here. Rachel, I saw you come in. Gloria, one day she'll come on. Okay, let's see. No. Okay. All right, so let's see if we can do this problem. Okay, I'm gonna erase this now. Is that okay, Stacia?
Yes, Professor.
Okay. So we have this x squared equal to 12. And it's set up perfectly like for what we call the square root method. We have x squared equals a number. We know the next step is to just set x equal to plus or minus the square root of that number 12. Now, 12 does not happen to be a perfect square, but it can be simplified because we know that the square root of 12 could be broken up into the square root of 4 and the square root of 3. And the square root of 4 is 2. So that my final answer comes out to be plus or minus 2 radical 3. Again, this is not one that could have been solved by factoring. And you could also, as I said, write it as two answers, as 2 radical 3 as one answer, and negative 2 radical 3 as your other answer. When you're this plus or minus symbol, if you have it, and we do have it on the Delta Math, if you look on the bottom where you have, it gives you this option to put in that symbol. It saves you rewriting it twice. Sometimes this is not so hard to type, but if you, some of them really involve quite a bit of typing. It's easier just to use this plus or minus sign so you don't have to write it twice. So that would be your answer in simplest radical form.
Professor, how do you get the 3?
the 12, remember what we did? We broke
Mhm.
12 into 4 and 3.
Yes. Mm-hmm.
The square root of 4, that when we take it, that just gave me the 2. That's where the 2 came from.
Okay.
The 3, I can't take the square root of, it's not perfect square. So that's why my answer became 2 square root of 3 or 2 radical 3.
Okay. Okay. Thanks. Understand.
Notice how this so much depends
Mm-hmm.
on being able to work with radicals,
Yes.
what we learned from chapter 6.
All right. Thanks. Understand.
Okay, let's go one step further. Can I erase this? Anybody still need it?
No, I'm still writing.
Okay. What if I had something like this? X plus 3 squared equals 9. What if instead of just having an x squared, I had a whole binomial squared? Now, one way of solving this is to actually do FOIL on the x plus 3, multiply x plus 3 times x plus 3, bring the 9 to the other side, and then solve that quadratic equation. I'm going to show you a quicker way of doing this. Using that same method, instead, I have something squared. I know when I have something squared, I can use the square root method. Taking the square root of this side will leave me just the x plus 3. The side that has the square just becomes, you just remove it. But the other side, you have to do plus or minus the square root of 9. Just like we did this one, we did x equals plus or minus the square root of 12. Over here, we do x plus 3 equals plus or minus the square root of 9. This then can get us to our answers. In this case, the square root of 9 is a perfect square. I could write that, I could simplify this to x plus 3 equals plus or minus 3. Because the square root of 9 is 3. It's not like this 12 that I have to simplify. It itself is a perfect square. But what does that mean? This really means that I'm going to get 2 answers. One answer I do by doing x plus 3 equals 3. And the other answer I get by doing x plus 3 equaling negative 3. I break it up. The plus or minus means 2 things. It means one answer is going to be positive, and one answer is going to give me, I'm going to use the negative. And now I just finish this off by getting the 3 to the other side. In this case, I get x equals 3 minus 3, which is 0. And over here, when I subtract 3 from both sides, I get x equals negative 3 minus 3, negative 6. And I get my 2 answers being 0 and negative 6. This is using what's called the square root method. I have something squared, I can take its square root, and by taking the square root of both sides. Otherwise, I would have had to use FOIL. I would have had to bring then the 9 to the other side. I would have then had to factor, and then I would have gotten my answers. I would have come out with the same answers, but this is a much quicker method called the square root method. Okay, I'm going to give you one to try now also. Let's say I gave you this one. suppose I gave you x plus 5 squared equals negative 36. See if you could use the square root method to solve this quadratic equation. Okay, let's see if we could work this one out. I'm gonna erase this one and I'm gonna write it over here. Again, we have something squared. In this case, it's a binomial x plus 5 squared equaling a number, negative 36. So if I use my square root method, which I can whenever I have just something squared on one side and a number on the other side, on this side I'll get x plus 5. On the other side, remember what we do? We do plus or minus the square root of the number. So whenever we're using the square root method, whether it's just an x squared or whether it's even some polynomial squared, I take the square root by removing the square on that side, and on the other side you do plus or minus the square root of the number. Now I'm at the point where I want to simplify. Now, until now, I would have said, oh, the square root of negative 36, you can't do that. Except we learned that the square root of negative 36 could be broken up into 36 and negative 1. And the square root of 36 is 6. And the square root of negative 1 is our famous new number I. So this comes out to be that x plus 5 equals plus or minus the square root, plus or minus 6i. And to finish this, I want to get the 5 to the other side to get the x alone. Now, this will give me x equals, now this negative 5 and the 6i can't be combined. They're not like terms. But I always want to put the real number, the number without the I first. So I'm going to put the negative 5 first. And then I get plus or minus 6i. When this number either has a radical or an I next to it, I could just bring this number to the front by changing its sign and put in the plus or minus. If you wanted to, you could have also written your answer as negative 5 plus 6i as one answer and -5 minus 6i as your other answer, because that's what this plus or minus means. But when these two can't be combined, you can just leave it with a plus or minus. If this would have been a plain 6, then I would have actually separated it because I could have combined them. But in this case, here would be your answer. Notice it involves just 2 or 3 steps. Step number 1, taking the square root of both sides. Step number 2, simplifying the radical. And step number 3, bringing the number that's next to the x to the other side. It's called the square root method. Are there any questions about this?
Professor, I think I made a mistake because when I saw the -36, I thought that there was no solution.
Right. So, and you're not totally wrong, because it depends on whether they say you can. Sometimes they say give your answer, only give real solutions. This is not a real number. This is what we call a complex or imaginary number. But we are, for this chapter, for we are allowed to use square roots of negative numbers. Actually, in no other chapter are we going to be using it. Any other chapter, except when I'm solving quadratic equation, but if I had anything else, I'd probably say there is no solution. So you were not totally wrong. It's just that since we learned about I, we can now use it as an answer. But we have to realize that the answer we're giving is
Not a real
a
answer.
complex or imaginary answer, not your standard real number.
Okay.
Okay?
All right.
All right. Now, I want to show you something called the completing the square method. Very interesting thing. Again, this method that I'm going to show you now, this is a very big time saver. But let's say I had a regular quadratic equation. Take one. I'm after I do a few steps. This process is going to take a little bit of of work. But after we've done this process, I'm going to show you how I can apply what we just learned here, the square root method. How I might apply it to other quadratic equations. In order to do that, I want to talk about what happens when we square a binomial. This sort of goes back to this third chapter that we learned. We know that when we're squaring a binomial, what it means is that you want to multiply x plus 5 times x plus 5. And in order to do that, you're going to have to use FOIL. So therefore, you'll get x times x, which is x squared. Outer will give you 5x. Inner would give you another 5x, because the outer and the inner are the same. And last will give you 5 times 5, which is 25. And of course, the outer and the inner are like terms. They could be combined. 5x and 5x is 10x. So that your answer to this whole binomial squared, to get x plus 5 squared, is x squared plus 10x plus 25. when you have a binomial that you're squaring, when you're multiplying a binomial by itself, you're going to end up with a trinomial. I'm going to show you a pattern. First of all, in my answer, if this is an x, then the first term is going to be an x squared. And your last term, this is a 5, your last term is going to be 5 squared, which is 25. So that's easy, but remember we're going to have FOIL. The first is the first square. The last is the last square. X squared is your first, 25 is your last. What about the O and the I, the outer and the inner? Well, if you were just to multiply these two terms together, the x times the 5, you'd get 5x. You would have to double that because you're really, for outer and inner, you're getting that 5x twice. So my middle term comes out to be x times 5, which is 5x doubled, and that's why it's 10x. So again, if I want to, I'm going to do another one. If I wanted to do x minus 7 squared by this shortened method, by just looking at the pattern, I know that my first term would have to be x squared. I know my last term would have to be the negative 7 times the negative 7, the negative 7 squared, which is 49. And the middle term would be the x times the negative 7, which is negative 7x, doubled, negative 14x. Do it the long way, and you will see this is exactly the answer you're going to get. I'm going to give you one to try. Suppose I ask you to do x plus 9 squared, the quick way. I'm going to give you just 1 second because this is quick. You should be able to do this by the quick method that I just talked about, just looking at the pattern. We're actually doing FOIL, but we're doing it remembering the pattern. What's the pattern? First term is going to be x squared. Last term is going to be 9 squared, or 81.
Mm-hmm.
And the middle term will be x times 9, which is 9x, doubled,
Mm-hmm.
18x. Look how quick that went. X plus 9. And again, you could do it by the whole FOIL, and you will see that this is correct. X squared, absolutely correct. Okay, now I want to go one step further. Suppose I had given you x squared plus 18x, and I left out the last number. And I told you this is going to be, if I put the right number there, this will be a perfect trinomial square. Just like x squared plus 18x plus 81 is x plus 9 squared, this is going to be x squared plus 18x plus something will be a perfect square. Well, we know what that something has to be. It has to be 81 because we have
18 square root.
But what if I hadn't given you that 81? Would you have been able to figure out what that number is? And yes, you could, because if you took half of this number, that would give you 9. You would know that you were dealing with x plus 9 squared, because this is always half of this number. Look at this, negative 7 is half of negative 14. And not only that, this last number of the trinomial, the number that doesn't have any x's, is this number squared, 9 squared. You would know it have to be 81. All we're doing, this is really not mathematics. This is just following patterns. Let's try another one. Suppose I gave you x squared minus 12x, and I left out that last number. And I said, I want you to put in a number here that will make this binomial complete the square. That's why this is called completing the square. Fill in the missing number that will make this into a perfect square trinomial. Well, remember what we said.
We could use 6.
Okay, you take half of that number, that's -6. In other words, this is going to have to be x minus 6 squared, because I know the number inside the parentheses is always half of that number. And the number that would have to have been added is this number squared, -6 times -6, which is plus 36. The missing number here is 36. And the answer written as a binomial squared is x minus 6 squared. So how do we find this 36? We take half of this number and square it. -6 times -6 is 36, and that gives us the binomial x minus 6 squared.
You said, sorry, you said take half of that number and square it?
Right.
Okay.
Okay. Is everybody clear so far? Okay, remember the method. Let's do one more. Let's do it with a y. Y squared minus 16y. Missing number. Okay, I want you to do two things. I want you to figure out what number this should be over here, the missing number that would make this a perfect square, and what is the perfect square? What?
Okay, so I think, could I go ahead, Professor?
Yes, I'd love you to.
Okay. I would have x minus 8.
Well, I hope you would do
Half of 16 is 8.
y minus 8.
Yeah, y minus 8, sorry.
How
And
did
the
you know
square-
it was 8?
Because I half of 16 is 8.
Right, and it's minus because this is minus, right?
Yes. And then the square root of 8 is 64. So to have plus 64.
And this number is always going to be positive, by the way, because even if you, when you square a number, it's always positive. If it, and -8 times -8 is 64. You are 100% correct.
Okay.
Is everybody okay with this? This is called completing the square. Completing. This was incomplete. We were missing a term. Putting in the right number over here makes it into a perfect square. It's called completing the square. Now, I'm going to use this completing the square method to solve quadratic equations. We're going to, in a couple of lessons, learn another use of this completing the square. How do we use it to solve a quadratic equation? suppose I had this equation, x squared minus 2x plus 5 equals 0. It's a quadratic equation. We want to solve this quadratic equation. Now, I just want you to notice, it can't be factored, because if you did the AC, 1 times 5 is 5, and I need two numbers that when I multiply would give me 5, but when I add would give me -2. There's no such, I don't know any regular numbers that would, which means my answer is not going to come out to be a regular rational number. It'll either be irrational, it'll be something with a square root, or be something with an I, but it can't be solved by the normal factoring method. So we already know one option. The option we know is using the quadratic formula. The quadratic formula always works. You can always solve a quadratic equation. You'll know it's an equation that will have an equal sign. You can always solve a quadratic equation, any quadratic equation, using the formula. But I'm going to show you an alternate method that we could use, this method called completing the square. Now, it's not as useful as the formula because I only use it when I have two things happening. The x squared stands alone. There's the a is 1. The leading coefficient is, in other words, there's no number in front of it.
Relax.
I'm sorry? Question? So that's number one. I want to make sure that the x squared, if I had something like a 3x squared, I'd right away go to the formula. Also, the b, the number in front of the x, has to be even because I'm going to want to divide this by 2. So that's it. Under those circumstances, I can either use the formula or the completing the square method. If I don't have those two conditions, that the leading coefficient, the a is 1, and that the b is an even number, I will immediately use the formula. And if you want to know the truth, I usually use the formula no matter what. But I think in the conditions where you can use the completing the square method, it actually is a little bit easier. In any case, how do we use that method? So step 1 is bring the c to the other side. Unlike the factoring method and unlike the formula method, you don't want this equal to 0. You want the x's alone on one side and the number that doesn't have an x on the other side. So the first thing I'm going to do is bring this 5 to the other side, so that my equation becomes x squared minus 2x equals -5. And if you notice, I left a space even though I brought that 5 to the other side. The reason is because now I have two terms of a which is almost a trinomial. It's two terms of a trinomial. I want to make this into a perfect square trinomial. I want to complete the square. So that, my second step, complete the square. Okay, I'm not going to write the steps for completing the square because we know what to do. We take half of this number, which is -1. I'm going to just write it underneath here. And I multiply it by itself. I square it. -1 times -1 is plus 1. In order to make this into a perfect square trinomial, I have to take half of this number and square it. Of course, then in factored form, this becomes x minus 1 squared. Now, I added 1 to this side of the equation. I better add 1 to the other side as well. So that's my next step.
Can I ask why did you add the 1?
Whatever you added on here, on this side to complete the square, add the same thing on the other side so that you've maintained your balance. Remember, this is an equation. I can't add something on one side without doing the same thing on the other side.
How did you get the 1, like on the left side, excuse me?
Okay, again, I take half of this number. Remember how we completed the square?
Okay.
Take the number in front of the x, which is -2, and you divide it by 2.
Okay.
Right? Remember this? -2 divided by 2 is -1. That's why I wrote it over here.
Okay.
And I multiply it by itself. -1 times -1 is +1.
Okay. Thank you.
Okay, so I add the number to the second side. These notes are only helpful if you really know the method and just need a reminder of what's going on. Okay, so now we have this x squared minus 2x plus 1, which we're writing in its factor form as x minus 1 squared. And on the other side, combining those numbers, -5 plus 1 is -4. And now I have the perfect setup for the square root. I have something squared equaling a number. That's just what we were doing before. Okay, so the next thing I'm going to do is just use the square root method. I'll go too low here. So just take the square root of both sides. So x minus 1 squared, when I take the square root, just gives me x minus 1. On the other side, we get, remember, when you're taking the square root, when you're solving the equation, you have to do plus or minus the square root of the number, which happens to be -4. And to finish it, I want to bring this -1 to the other side. So I'm going to add 1 to both sides because I want the x alone. So this will be, remember, the number that I bring in the over, I always put first. It's 1 plus or minus. Hey, what's the square root of -4? Square root of -4 is the square root of 4 and -1. I'm simplifying it, which is 2i. So my final answer becomes 1 plus or minus 2i. Okay. I want to do at least 2 more like this before I give you one to try. Can I erase this? Okay, let's try another example. Okay, here's an example. I'm going to leave the instructions on so you can keep track as to what you're going to be doing. Okay, here's the quadratic equation I want you to solve. I'd like you to solve it using this new method called completing the square. Notice it'll work because this number in front of the x squared is 1, the leading coefficient is 1, and the number in front of the x is an even number, so it's easy to take. You could use the completing the square on even if you don't have those two situations, but then you're going to end up with hard fractions. I don't want to do things that involve hard fractions. So again, you won't be involved with fractions if this is just a plain x squared and this is an even number. Now, I'm going to give you a few minutes to try it on your own. And then I'm going to show you how we could have done it using the completing the square method and how we could have also done it using the quadratic formula method. Okay, let's get started on this. The first thing is I'm going to do it using completing the square method. Then I'm going to go back and do the same thing using the quadratic formula so that we can see which method you would prefer. Because truthfully, I don't care which method you use. If both of them work, then you can use either method that you prefer. Because even though it might say use the completing the square method, or it might say using the formula method, all you're going to be asked for is an answer on the final exam. So therefore, you can do it either method you want. Okay, so the first step, we have this x squared plus 8x equals 5. If we're going to be using the completing the square method, we know that we have to have the x squared and the x on one side and the number on the other side. And the number in front of the x squared has to be 1. In other words, the x squared should stand alone. And the number in front of the x has to be an even number. And we have all of those situations. We're right up. We don't even have to do step number 1 because the standalone number, is on the other side. In other words, for completing the square, you want just the x's on one side, and any number that doesn't have an x has to be on the other side. And then what we're going to do is we're going to complete the square by taking half of the number in front of the x, which is, this is an 8, so half of it is going to be a 4, and multiplying it by itself. 4 times 4 is 16. I'm going to have to add 16. But if I add 16 to one side, I have to add the exact same number to the other side, which gives me, on this side, x squared plus 8x plus 16, which I can write as x plus 4 squared, because now it's a perfect square and I can write it in its factored form, equals 5 plus 16, which is 21. Now we take the square root of both sides. The square root of the x plus 4 squared is just the x plus 4. On the other side, we do plus or minus the square root of that number, which is 21. And I look at this 21, the square root of 21 can't be simplified any further because the only thing 21 breaks up into is 7 and 3. Neither of those are a perfect square. So all I have to do is bring this 4 to the other side. So I subtract 4 from both sides. And that gives me x equals -4. Remember, I always put this number that I'm bringing over first, plus or minus square root of 21. And you can leave your answer like this, or if you wanted to write it as two separate answers, your answer would be -4 plus radical 21 as one answer, -4 minus radical 21 as your other answer. Remember, the plus minus means there are two answers, one where you're adding and one where you're subtracting. And notice, here is our steps. We completed the square, we took the square root, and then we simplified as much as we could. Just to show you that we could have done this using the quadratic formula. Remember, here is my equation. X squared plus 8x equals 5. That's the equation we started with. If I want to use the formula, I have to have it equal to 0. So I have to bring the 5 to the other side. So that would give me x squared plus 8x minus 5 equals 0. Remember, our formula let's just write, this is the formula method, is negative b plus or minus square root of b squared minus 4ac over 2a. So we know that my a is 1, my b is 8, and my c is negative 5. So sticking it into the formula, negative b, so negative 8, plus or minus the square root of b squared, that's 8 squared, minus 4 times 1, my a, times negative 5, all over 2 times 1, because my a is 1. Okay, let's simplify. So it's negative 8 plus or minus, now 8 squared is 64, and negative 4 times 1 times negative 5 is plus 20. So this is the square root of 84 all over 2. And the square root of 84 could be broken up into 4 and 21. Square root of 4 is 2. So this comes out to be negative 8 plus or minus 2 radical 21 over 2. And I could divide all three of these terms by 2. So negative 4, 8 divided by 2 is negative 4. 2 divided by 2 cancels. 2 divided by 2 is 1. So my answer comes out to be negative 4 plus or minus radical 21, which is exactly the answer that we had gotten before. This is using the formula. Personally, I think the completing the square method is easier. There's a lot less simplifying if it makes sense to use the completing the square method. But if you like only using the formula, you're familiar with the formula, you only like the formula, you know how to use the formula, go ahead and use the formula, because you will get the exact same answer. Just make sure you're careful about simplifying. Okay. Stacia, don't forget that there should be square roots. It's probably you can't put the square
Yeah, I can't put in the square root.
roots. Okay. All right. Should we try another one?
Yeah, we can.
Okay, so let me erase this and give you another one to try. You should know I'm taking these off of old finals so that you can try it either way. X squared minus 4x plus 29 equals 0. Now, I'm going to give you the choices. This is a multiple choice. I'm going to give you the choices. I don't think we need this anymore. And you can choose. It says use the quadratic formula, but I am going to let you choose the method that you want. Okay, so here are your choices of possible answers. 7 and negative 3, choice 1. B, 4 plus or minus 10i. C is choice C is negative 2 plus or minus 5i. And choice D is 2 plus or minus 5i. So here are your choices. let's see which example, which choice you're going to figure out. All right, I think we should start working on it together because there isn't that much time left to the period. I see that this could actually work very nicely with the completing the square method. Even though it said to use the formula, I'm going to use the completing the square method and see how that works out. So if I want to use the completing the square method, the first thing I have to do is bring the c term to the other side. I can only have the x terms on this side. So I'm going to subtract 29 from both sides, which will give me x squared minus 4x equaling negative 29. Okay, now I'm going to, I see this is a x squared, or just a 1. The a is 1 and the b is an even number. I take half of this number, half of negative 4 is negative 2. I'm going to write it over here. And I square it. Negative 2 times negative 2 is positive 4. I add 4 over here to complete the square. But whatever I do on one side, I do on the other side as well. Since I added 4 over here, I've got to add the 4 over here. And this in factored form is x minus 2 squared. I don't even have to think about it. Whatever half of this number is the second number that goes in the parentheses of the binomial. The first is always the x, and the second, the number is always half of this. So that's the x minus 2 squared. On the other side, I have negative 29 plus 4, which adds up to negative 25. And now I take the square root of both sides. The square root of x minus 2 squared is just the x minus 2. Then it becomes plus or minus the square root of this number, negative 25. Well, the negative 25 could be broken up into 25 and negative 1. Remember, any negative number in a square root is an I, so that this becomes 5i. So I get x minus 2 equals 5i. and I bring the 2 to the other side. Oh, I forgot the plus or minus, sorry. My answer becomes x equals, remember this number always goes first, 2. Here's my plus minus 5i. These are not like terms, so I just leave it separate like that. Any questions about this?
Professor, when I did it, when I reached the when I add the 29 plus the 4, instead I got 25.
I'm sorry, I didn't hear what you had said.
Okay, I'm saying, right, when I messed up with the sign with the negative 29 plus the 4, I got 33 instead of 25.
This is a negative 29.
Yeah,
Be
that's
careful,
where I
'cause-
messed up.
Okay, yes, and you probably saw that none of these answers worked.
Yeah.
So that's a hint to go back and try again. But if you notice, my answer was choice D. And look at how carefully you have to look, because choice C is almost identical. The difference is the sign of the 2. And the 2, it was x minus 2. So when you brought it to the other side, it became a positive 2. So the correct answer, and I'm telling you, they do this purposely. They want to trip you up. You have to look carefully. All right, I think we're going to stop right here. I'm going to leave Melissa in charge. Should I continue the recording or should I stop the recording? Melissa? I think I'm going to stop the recording now. I don't know that you need the recording anymore. Oh, I can't stop the recording because Melissa's in charge. Melissa?
Yeah.
I think you can stop the recording. It's up to you.
Okay.
Okay, I'm leaving now. Have a great day, everybody.
Bye, Professor.